Hello, this is the luckiest maths teacher in the world. Today we're learning scientific notation and significant figures. I know we've already covered significant figures, but we're going to look at them in the context of scientific notation. Okay, so what actually is scientific notation? So scientific notation is a way of representing very small or very large numbers using powers of 10. Basically, we're taking numbers that have lots and lots of digits and we're just writing them in a much easier to be understood way. Now, there is convention for how we do this. We do it by writing the number as something times 10 to the power of something, okay? Now, this something here is always between 1 and 10. Okay, now when I say between 1 and 10, it doesn't have to be a whole number. It could be something like 2.235 or whatever. And that's where significant figures will come in. This number here, that's in the power, that is going to be positive or negative. Okay? And it's going to be a positive or negative integer, which means whole number. So by writing it like this, it will be easier to understand what the number actually is. So because it involves powers of 10, that's why we're doing it in this section on indices and surds, all right? So let's look at a few examples. Now, if you have a number in scientific notation, it's really easy to turn that into a basic number, a number that's not written in scientific notation. All we're doing here is a basic multiplication. Now, hopefully you already know that if I have something like 10 to the power of a whole number, positive whole number, then that tells you, then power tells you how many zeros go on the end of it. So 10 to the power of 4 is 1 with 4 zeros, 10 to the power of 3 is 1,000, 1 with 3 zeros. So this one is just going to be 2.35 times 1,000, and I know you all know how to do that. It's 2,350. But now I want to show you one with a negative power. So now I'm going to do this example here, express 3.2 times 10 to the power of negative 2 as a basic number. So I'm going to do this one here. So this relies on something that you may not know already, and that is that a to the power of negative b is the same as 1 over a to the power of b. So if you have 10 to the power of a negative number, it's just the same as 1 over 10 to that number. Notice here though, not only have we taken this and put it on the bottom of the fraction, we've changed the power from negative to positive. So to give you an example, 10 to the power of negative 2 using this rule is 1 over 10 to the power of positive 2, and I'm sure you all know 10 squared is 100. So this is 1 over 100, okay? I know that this probably seems counterintuitive. A lot of people think, oh, 10 to the power of negative 2, well, that's got to be minus 100. It's got to be negative, okay? Now, I'm going to have to ask you to trust me on this because we are actually going to look at this in more detail in a few lessons. The reason this is true, the reason, say, 10 to the negative 2 is 1 over 100 and is still a positive number, is to be in accordance with other index laws. So we will go through that, but for now, just trust me on this. So back to our question. Express 3.2 times 10 to the negative 2 is a basic number, so it's 3.2 times 1 over 100, okay? Now, the way that we look at this is the same as 3.2 divided by 100. Now, remember how we do division? If we are dividing by powers of 10, all we do is move the decimal point a certain number of places to the left, okay? Okay, and similarly, if we want to times by a power of 10, we move the decimal right. Now, the number of spots you move the decimal is equal to the number of zeros in the power of 10. So a power of 10 is just going to be 1 with a whole heap of zeros. So 100 is a power of 10, 1,000, a million, 200 is not a power of 10, nor is 2,500 or whatever. So to do 3.2 divided by 100 is nice and easy. So I'm going to write it again down here. So I got 3.2. Now I need to move my decimal point to the left because I am dividing by 100. And because there are 2 zeros in 100, I move it 2 spots left. So if I move it one spot to the left, then I've run out of numbers. I've run out of places to move it. So what I do is I insert a 0 there. And then I move it over again. So the decimal point is here. So then 3.2 divided by 100 is 0.032, okay? Now we're going to look at it the other way. We're going to be given a really big or really small number and put it in scientific notation. We're just sort of reversing the idea that we've just used here. So I'm going to do each of these questions separately. I'm going to express 72,489 in scientific notation, and I'm going to express, that should be 0.003614 in scientific notation. Now, in both cases, my goal is the same. I want to write it as some number between 1 and 10 times 10 to the power of some whole number. What I essentially am going to do is reverse the ideas that I just showed you in the previous example. So in the previous example, I had a number in scientific notation and I wanted to write it like this or like this. Whereas, in this case, I'm doing the opposite process. So what I'm going to do is I'm going to write my number 72,489. So, what I want to do is I want to change this so it is some number between 1 and 10. So I know that 72,489 is just the same as 72,489.0. So I put the decimal point here. Now to make this into a number between 1 and 10, I need to move the decimal point. So I'm going to move it 1, 2, 3 spots, and then it's 72.489. That's not between 1 and 10, so I move it again. And I'm left with 7.2489. Clearly, that's between 1 and 10. Now, what did I have to do to get from here to here? What I did was I moved the decimal point 1, 2, 3, 4 spots to the left. So in other words, what I did was divide by 10 to the power of 4. So if I divided by 10 to the power of 4 to get from here to here, I want this still to be the same number, so I want to make this thing here into the same number as above. Then instead of dividing by 10 to the power of 4, I need to cancel that out by timesing by 10 to the power of 4, okay? So 7.2489 times 10 to the power of 4. If I go and do this, I move the decimal point 4 to the right and I get the answer I started with, okay? So let's try the next one. Same process. So I write my number, 0.003614. So I move the decimal point as many places as I need so that I end up with a number between 1 and 10. So if I move it 1 spot, it's not between 1 and 10. Move it 2 spots, I have 0.3614, which is less than 1. I need to move it a 3rd spot. And then I get 3.614, again clearly between 1 and 10. Now what I had to do to get from here to here was I had to move the decimal point 1, 2, 3 spots to the right. So I had to times by 10 to the power of 3. So this number here, because it's been times by 10 to the power of 3, if I want it to be equal to this number here, I need to divide by 10 to the power of 3. The thing is, scientific notation has to have a times. So dividing by 10 to the power of 3, which is 1,000, is the same as timesing by 1 over 10 to the power of 3. But when I went through negative powers before, I told you that a to the minus b is 1 over a to the b. So reversing that process, 1 over 10 cubed is the same as 10 to the minus 3. So this number is equal to 3.614 times 10 to the minus 3. Now it is in this form up here, like I wanted. So here's a little rule of thumb for you. So if I have a number that's greater than 10 that I'm putting in scientific notation, like I had here, 72,489, clearly that's more than 10, then the power is going to be positive. If I have a number less than 1, like I did here, the power is going to be negative. Now, if you have a number between 1 and 10, well, there's no need to put it in scientific notation anyway, okay? So I'm just going to do one more example of each type so that we get it really quick. So let's say I have the number 336,458, okay? So to put this in scientific notation, I want it to be between 1 and 10, so it's obviously going to be 3.36458, like that. Now to do that, I would have had to move the decimal point 1, 2, 3, 4, 5 spots. So it's going to be times 10 to the power of 5. Now, I know that this answer is right because this number is more than 10, so my answer should be positive power. So I'm all good with that. Another way you can think of it is this is 336,458. So I've taken 3.36458 and I've had to times that by 100,000, which is 10 to the power of 5, okay? One more example. If I have 0.0023719, something like that. So again, I want to make this a number between 1 and 10, so that's just going to be 2.3719. Now to do this, I've moved the decimal point 1, 2, 3 spots. So it's going to be 10 to the 3, but because my original number, as I said before, was less than 1, this will be a negative, okay? A way you can think of doing small numbers is the number of zeros after the decimal point here, add 1 to that, and that gives you the negative power. So if I have 0.000006 or whatever, then it's going to be 6, and because there are 5 zeros after the decimal point, it's going to be 10 to the power of 5 and negative, but I need to add 1, so it becomes 10 to the power of negative 6, like that. Okay, now I'll quickly go through significant figures. So remember, significant figures are the number of digits in the answer, but not including zeros at the start and the end. Okay, so let's say I wanted to take this one here, this answer that I've got, and I want to make it 3 significant figures. So that means I have 3 digits in my answer, so I round it to 3 digits, but I don't include zeros at the start or the end. So this would just become 3.36 instead of 458. So I've rounded it down, because the next one is 4, times 10 to the power of 5. To 3 significant figures, okay? If I wanted to do this one to, let's say, 2 significant figures, it'd just be 2 point, now because the third significant figure is 7, 5 or more raise the score, I'm going to make this 2.4 times 10 to the power of negative 3. So the powers don't count in significant figures. All right, hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.